So lastly, what we learn what is ANN. Okay, and basically we just like get an idea about neurons, and like we just try to actually, like we just decided to train a single neuron actually. Okay, so we want to just mimic the human brain. So for that, we must have an idea about the neurons. Okay, we want to just copy a human brain. Then firstly, we must have an idea about the neuron, how the human brain works. So for that, what we did, we just get an idea about the human brain. So we just got an idea that there is a neurons in human brain, and there are actually 10 raised to 11 neurons, and one neuron connect with another actually 10 raised to 3 or 10 raised to 4 neurons. Now we just consider if like there is a communications, like if we just assume that if you have a like one, if you want to just transfer one data from a neuron to neuron, in short neuron A to neuron B, and it takes 1 millisecond. If it takes 1 millisecond, then one neuron connected to another one, otherwise there are total 10 raised to 10 raised to 11 neurons, then maybe it requires actually 10 raised to 11 milliseconds. That's too much time. So what's there in our brain? Our brain actually follows the 100-step rule. What is the meaning of that 100-step rule? Like more than 100 passing, like otherwise more than 100 milliseconds are not allowed. Actually, more than 100 passing are not allowed in sequential way. Okay, in parallel way, maybe there are actually 10 raised to 11 passing, but more than 10 raised to, sorry, more than 11 sequential passings are not allowed. So that's something about human brain, and we just discussed something like this is a neuron actually. And as per the previous session, we just conclude one thing. In this neuron, there are some input and one output is that. Okay, there are some inputs, so these all are the actual input, these all are the inputs. Okay, and this is the output. This is the output. And this is in this nucleus. What is this nucleus? Nucleus is this one. So it's a cell type of thing having a decision power. So what this nucleus generally does, it has actually two functions. Let us just try to represent, otherwise describe this one as a mathematically. So it has basically two functions. The first one, the first function is actually an integrating function. That means it just collect all the inputs and some of them, and one prediction it will do. So what will be the prediction value? So if the prediction value, let me say we have only two prediction value, we are just try to actually predict, otherwise try to deal with the binary classified problem. So maybe there is a 1 or 0, two prediction value, otherwise 1 and -1, two prediction values are there. Okay, so what we want to do, if if the decision, otherwise if the outcome is actually greater than 0, then do something, otherwise do not something. So we have another function, that is activate function, which does this task. It has a threshold. If your integration value greater than threshold, okay, otherwise it is less than threshold, then we have to do if it is greater than threshold, then do something, otherwise do not something. Do something in the sense pass the data to the next neuron, otherwise do not do anything actually. Okay, so that's that. So we will have actually two types of functions over here. We just conclude that thing. The first one is actually integration function, another one is nothing but an activation function. But here, guys, the problem is, let me once again recall that thing. Consider we have an order to our mind from actually to different position, to different parts of our body. The first is actually leg and another one is actually hand. Okay, हमारे mind में actually दो अलग-अलग जगह से मान लीजिए order आया. So like to which one our mind will give a priority? So that's the thing. उसको कुछ task perform करना है, but which task? Okay, मान लीजिए मुझे पैर में भी पेन हो रहा है, otherwise there is something, and on my hand also there is something, like I just hold something and I wear shoes, tight shoes I just. So मेरे पास दोनों प्रॉब्लम, हाथ में भी कुछ प्रॉब्लम्स आया because I just hold some weighted thing. तो वहां पे भी weight का issue आ रहा है, and I have some problem in my like in my feet also. So what to do? So my brain just got idea from two different places. So for that, actually we have to just assign the weight as per the priority. For the priority purpose, we have to assign the weight. So all these input are nothing but a weighted input. All these inputs are nothing but a weighted input. So our this sigma type of thing, that's nothing but an actually integrating function. It just sum up all this thing. In short, the formula of this one is actually xi wi. What is x? That's nothing but in my feature as per our model, or as per our data set, that's the feature, or as per the neuron, you can say that that is nothing but input. What is the w? It's nothing but an weight. Okay, and this is nothing but an activation function, and this is the step activation function. Either it will do something or it will not do anything. Okay, so that's that. So after that, we discuss some actually functions, activation function, step function, the ramp function, sigmoid function, and finally rel. Okay, we discuss all this thing. So now, in today's session, what we will do, we will just try to like learn a perceptron algorithm. What is that perceptron algorithm? I want to train a single neuron. I want to train a single neuron. So guys, we have to learn that algorithm. If you want to train a single neuron, then we have to actually like sorry, this perceptron is nothing but an algorithm to train a single neuron. So this is the algorithm, guys. That is actually like quite old. That was actually declared in 1962. Okay, that was actually declared in 1962. So now this is an algorithm. So let me just go in a flow. So what this algorithm says, it's nothing but an perceptron algorithm is nothing but an iterative algorithm. What do you mean by iterative algorithm? Iterative in the sense there are some loop. Okay, it just performs the same task repeatedly. That is iterative algorithm to learn the weighted vector. What is the vector? Vector in the sense you can say that it's a one-dimensional array. It's a one-dimensional array, and it's a weighted in the sense some weights are there. Okay, basic idea is update the weights. In short, this is your input. This is your input. Now update this input. It's not a feature. I'm not talking about the xi. Okay, this is not xi. That is actually wi. हमारे पास दो चीजें थी xi and wi. So right now we are just talking about the wi. What is xi? तो हम लोग एक सिंपल सा मान लो जी एग्जांपल ले लेते हैं कि लाइक मुझे आइरिस डेटा सेट पे काम करना है. I want to work with the iris data set. Okay, so iris data set में मेरे पास चार फीचर्स थे. पेटल लेंथ, पेटल विड्थ, सेपल लेंथ एंड सेपल विड्थ. एंड उसमें एक्चुअली तीन आउटकम थे. Okay, flower 1, flower 2 and flower 3. So right now it's a multi-classifier problem, but we will just consider two classes. Okay, flower 1 and flower 2, third value we will not consider. But that we will discuss later, but I want to just say one thing, like there are four features. So that is nothing but an xi, that is nothing but an xi for this perceptron algorithm. Okay, but what about wi? So wi is nothing but, otherwise what is w? So w is nothing but an actually weight vector. Okay, that is nothing but a weight vector. So what we will do, just consider some weight vector as an initial position. On initial position, just consider some weight vector. xi is given because that's in our data set. Okay, so what we have to do, perceptron algorithm, it's an iterative algorithm to learn the weight vector. In the sense, final conclusion is we want to just find the proper weight. Okay, like हम लोग का target क्या? What is our target? We want to find out the particular weight we want to just find out. जैसे में हम लोगों ने काफी एल्गोरिदम में हम लोगों ने ऐसा कुछ किया था कि हम लोग एक्यूरेसी पे फोकस करते थे, कोई एल्गोरिदम में एरर रेट पे फोकस करते थे. On this, in this perceptron algorithm, we have to focus on actually weight. So in the initial days, we will just consider some random values for the vectors, weight vectors. So, and then what we will do, basic idea is update the weights in proportional to error contributed by the inputs. Okay, so whatever the error you will get, just update the weight as per that. मान लो आपके पास error काफी ज्यादा है, then update the weight. If error is 0, then do not update the weight. If error is 0, then do not update the weight. That is the concept. That is the basic concept. Okay, iterative algorithm it is, and we will just take some like initial weight vector, and we will just update that weight vector. Okay, and how to update that? So for that we have one actually. For that we will focus on error. So if you will get error, just update the weight and just try to decrease that error. Try to downgrade that error. If you have no error, just use the same weight vector for the next step also. Why next step? Because it is an iterative, so you have to perform the same step repeatedly. So now let me just go in a like flow, randomly initialize weight vector w0. So that is considered the initial weight is nothing but in w0, but it's a weight vector. So consider if you have four if you have a four x values or four features values, then your weight vector will have actually four values. Okay, your weight vector will have actually four values, and maybe it will be -1, like you can just write down, like you can just set actually 20, you can just set actually 0. That's up to you. Randomly you can just set anything like -7.2, anything you can just use. So consider this is my initial weight vector. That is my initial weight vector, and that is nothing but an w0. Okay, now what is that? Repeat until the error is less a threshold. Just ignore this threshold right now. Okay, इस threshold को अबे ignore करिए. So until repeat until to just reach a max integration. Sorry, make actually to reach at actually max iterations. So consider मैं अभी max iteration की value 10 दे लेता हूँ. So 10 times we have to repeat this thing. So guys, in this algorithm we have two loops. Okay, this is outer loop and this is the inner loop. हमारे पास यहाँ पे दो loop, outer loop and inner loop, because it's an iterative algorithm. So now the first question is outer loop कितने time execute होगा? Outer loop कितने time execute होगा? So the thing is outer loop या तो आप एक fix value ले लीजिए, max iteration is 10, max iteration is 10. So या तो आप fix value ले लीजिए कि हम लोग को 10 times ही execute करना है, otherwise you have to just continue the same thing up to the error is less than a threshold. Error is less than a threshold. But what is that? Just ignore right now. Okay, threshold we will discuss later, but just right now just consider repeat for max iterations, and मैं यहाँ पे m का value 10 consider. Another thing is inner loop में क्या होगा? For each training example xi in the sense like मान लीजिए मेरे पास 100 records है. Okay, मेरे पास 100 records है, then xi is nothing but an, for the first record it's nothing but an like vector of 4 values. Why vector of 4 values? अगर हम लोग iris dataset को focus करें, then in iris dataset we have 4 columns: petal width, petal length, sepal width, sepal length. Okay, so for the first record I will get 4 values. Okay, for the first record I will get 4 values. So for each training example, so अगर आपके training example में मान के चलिए आपके training example में आपके पास 100 records है. Okay, आपके पास training data set के अंदर 100 records है, तो उसमें से एक यहाँ पे ऊपर बार बनाने का मतलब it's a vector. ऊपर बार बनाने का मतलब it is a vector. तो उसमें से एक value fetch करें. Okay, एक value fetch करें and वो value fetch करने के बाद हमारा next task क्या होगा? It's a vector. Why it is a vector? It has all the feature values. So maybe आपके कोई data set के अंदर 10 feature values है, then xi is nothing but a vector with the 10 values, or a vector of 10 size. In iris data set, it's nothing but a vector of 4 size. And what about ti? Ti is nothing but an actually like outcome or classifier or labeled value for that particular row. For that particular instance, it is nothing but a predicted value, or not a predicted, it's actually a labeled value, or you can say that class value. So consider that's actually flower one type of thing. So why pi is nothing but a flower. Okay, for the second record, consider it's actually flower 2. So for ti, it is nothing but a flower 2. Fine, so that's that. So for each training example, we have to just take a feature value and we have to take outcome value. Now what we have to do? Now predict the output yi. In short, just like predict the outcome. That's nothing but a yi. Using the current network weights wi. For the yi, what you have to do? For the yi, you have to just do one thing. You have to just use this actually previously generated weighted vector. So for the first iteration, you have to just consider w0. So now consider w0. I just consider w0 is actually 1, 2, 3, and -4. Why I just consider 4 values? Because I'm just trying to explain the same thing in the context of actually iris dataset. Okay, with reference to iris dataset. So in iris dataset there are 4 features. So I just consider this w with the actually size of 4. Actually in practical it will be with the size of 5. Okay, एक और value हम लोग को add करनी होगी. That is nothing but an actually y-intercept, or you can say that it's nothing but a bias. But right now just ignore that bias also. So हमने दो चीजें ignore. एक तो w0 में actually like xi size of x plus 1 values होगी, but we just consider w is nothing but n, the size of w is nothing but n size of x. What is that x? It's nothing but n feature vector. And we just ignore one more thing, that is a threshold. Okay, हमने एक और चीज यहाँ पे ignore किया, that is threshold. So now this is nothing but a w0. This is nothing but a w0. So that is w0 value. So now for the first iteration, what we will consider, we have to just consider this w0 and we have to just predict the outcome. But how to predict the outcome? How to predict the outcome? Outcome predict करने के लिए तो हम लोग perceptron plan कर रहे हैं. But guys, like just recall the previous one. So यहाँ पे हम लोगों ने कुछ algorithms discuss, sorry, कुछ functions discuss किए थे, and one of the function is nothing but an integration function, and another one is nothing but an activation function. One of the algorithm is nothing but an integration function. So what integration function says? Integration function says, just do this wixi and wixi के path with sum of them. ओके अगर मेरे पास I की वैल्यू लाइक मेरे पास 4 फीचर्स है then the value of I will start with 1 ends with 4, so we have to perform the same thing for 4 times. So W we considered, okay, in our example W की वैल्यू हमने consider कर ली थी, that is actually 1 2 3 minus 4, and XI is nothing but an original value of the first record. तो फर्स्ट रिकॉर्ड में मतलब जो भी हमारे पास वैल्यूज थी that is nothing but the value of xi. So guys, what we have to do, we have to just multiply all this thing and we have to just sum up them. ये sum up करने के बाद हम ये जो आंसर आया वो हम एक्टिवेशन फंक्शन को दे देंगे. We will just forward that thing to the activation function. An activation function having some threshold, so consider the threshold is nothing but a zero. Threshold is nothing but a zero. So we want to do one thing. अगर इससे ऊपर मतलब अगर आपका प्रेडिक्शन आपका इसका आउटकम ग्रेटर देन जीरो आ रहा है या लेस देन जीरो आ रहा है, otherwise let me say greater than equal to zero आ रहा है और less than zero आ रहा है. If greater than equal to zero then flower one type of thing, okay, otherwise flower two type of thing. देखो गाइज मैं once again रिपीट कर रहा हूँ, मैं सिर्फ बाइनरी क्लासिफायर पे फोकस कर रहा हूँ. इन आयरिश डेटा सेट देयर आर 3 flower type of things. Okay, 3 class labels are there, but right now just discuss for the binary. After that onwards we will just discuss for the multi classifier like algorithm also. Okay, so right now just consider it's a binary classifier. Let I just repeat what we did. हम लोगों ने prediction किया. कैसे prediction किया? We just use like activation function and integration function. Integration function for the sum up of wi and xi. And what about activation function? So we just set a threshold 0. अगर greater than equal to 0 आंसर आ रहा है, consider the like जो आपने input किया, जो features value आपने provide की, the outcome for the that feature value is nothing but actually flower 1, otherwise that is flower 2. ऐसे हमने predict किया flower 1 and flower 2. Okay, so ऐसा कुछ मुझे यहाँ पे prediction मिला. So now predict the outcome yi. So yi just say, oh, that's flower 1. But what about the actual value? So actual value just say, oh sir, that is flower 2. This data is for flower 2. So ti minus yi, what is the ti? Ti is nothing but an actual value. What about yi? That is actually a predicted value. Okay, that is actually a predicted value. So ti minus yi, it's nothing but an error. In actually ensemble modeling, especially in GBM, we just learn one thing, that is square up error. Okay, that is actually like y hat. So what is that y hat? That is actually y minus f. What is that y? That's an actual value, and f is nothing but a predicted value. So y minus f, that's nothing but a y hat. So here that is considered. We are just using a simple error function. So ti minus xi, that is ti minus yi, that's nothing but an error. So now what's our target? Just focus on our target. We want to just update our weights. Okay, we want to just update our weights. So I will now compute a wn plus 1 by using the all w value, all w in the sense that's a weighted vector, all w value plus this is nothing but an eta. N type of thing is nothing but an eta, that's the constant. Okay, that is actually learning rate, how fast you want to learn your algorithm. That is how fast you want to just learn a next weighted vector. So the general value of the value of this eta is in between 0 to 1. In between 0 to 1. And generally it is considered as right now it's considered as 0.1 or 0.2. Generally it will be in approx nearest to 0, 0.1, 0.2, something like that. Now what about this ti minus yi? That's nothing but an error. And what about xi? Xi is nothing but a feature value. Xi is nothing but a feature value. So now consider this is my w0 and my feature values are actually 1.1, 2.1, 3.3 and 0, otherwise 1. Just consider this. So this is my wi and this is my xi. Just sum of them. Wi, xi ka sum up kariye, you will get some positive or negative values. Okay, so as per that positive or negative value, we will predict the outcome. So consider that our predicted outcome is nothing but in yi, and now just compare yi and xi, yi and ti. If both are same, guys, अगर मुझे सेम मतलब परफेक्ट अगर मुझे आउटकम मिला, दैट मींस व्हाट, yi minus ti या ti minus yi क्या होगा, it will be 0. It will be 0. तो ये पूरा पार्ट 0 हो जाएगा, because 0 into something, that is 0. 0 into something, that is 0. So wn plus 1, it's nothing but wn. So what we discussed, if error is less than threshold, otherwise if there is a no error, then same weight vector you have to use for the next iteration. Same weight vector you have to use for the next iteration, because मान लो मेरे पास 100 records है, For the first record, it just it just predict a perfect thing. It just predict a accurate thing. Then we have to use the same vector for the second row. We have to use the same vector for the third row and all this. Okay, जहाँ पे changes आ रहा है, what we have to do as per the error rate, because this is nothing but an error. This is nothing but an error value. So as per the error value, what we have to do, we have to change our weight vector. And finally, just apply the same procedure for 100 times. Finally, apply the same procedure for 100 times. But now what's the problem? The problem is, consider for first 10 records, I use the W0, because for first 10 records, this W0 predict the actual value. Actual value and predicted value are the same. So predict the actual value for first 10 records. But from the 11th to 30th record, the weight vector was changed. Okay, so I cannot use the same weight vector, because and actually 1 to 10 the weight vector is weight vector is different, and from 11 to 25 the weight vector is different. So what I have to do, I have to just use the updated weight vector for 1 to 10 also. So what we are doing, this inner loop will just generate a next weight vector. So once you just find the new weight vector, we have to examine the same weight vector for all the rows. So what we will do, once again, let me just move to the outer loop. So consider here the value of m is 10. So outer loop once again starts with that weight vector, and apply that weight vector on the first record and the second record and so on. So finally, once again, it will be applied to all the 100 records. You will find a new weight vector, do the same procedure for the 10 times, and finally you will get actually like a perfect weight vector with actually minimum error rate, otherwise with zero error rate. So this is the actually algorithm. And outer loop is generally known as epochs, or someone just say it is nothing but in batches. And inner loop just generally known as mini batches, or inner loop it is known as. Mini batch we will discuss on after some time. We will discuss we will just discuss some more thing on this inner loop, but that's it. So what is that eta? It's a constant. So what about this threshold? We didn't discuss up to this. Okay, what we are just doing, हम लोग 10 times इस loop को execute करने वाले. We just taken fixed value for the simplicity, and for this W0 we just do one thing. It's nothing but in size of this W0. It's nothing but in size of actually accuracy. Okay, हो सकता है कि वहां पे actually हम लोग को कुछ bias भी add करना पड़े. Generally we have to add the bias. So that algorithm was declared in 1962. So is there any problem, guys? Is it clear? Maulik sir, Vijay sir, fine. So let me take an example. Okay, so we will just get a better idea how this algorithm works, and is this a proper algorithm or not, because it was introduced in actually 1962, and right now that's 2021. So is it a better algorithm or not? So let me just try to take let me just take an example and try to learn this one in detail. So guys, in this example,